Yeah, okay. All right, will you please, let's go ahead and put your computers away, calculators away. We're gonna talk about our first actual calculus topic, which is called limits. All right, so limits being our first topic, you're like, I've never heard of a limit. What is a limit? If you were to look it up in that textbook that you just checked out, it would say for some function f of x, as x approaches c from both sides, f of x approaches L, the limit of f of x. It's very difficult to read that and understand what that is. So let's talk about this definition and kind of break that down. So a limit is a y value on a graph. It's the y value that you approach as you trace out the x value from both sides. Like, why in the world do we need limits if you can't just like simply figure out what the y value is of a function, right? Like, do we really need limits? Limits come up a lot because oftentimes there are holes in graphs. Think of all the crazy equations you've done. Any of them that have a denominator might have an asymptote or a hole or like something weird happening on the graph. So limits help us find out what would the y value be if you approach from both sides. And it's valuable to know that because sometimes you have a y value that doesn't actually exist. And so you just are looking at the behavior like as you get closer and closer and closer to that point. It's like, what should the y value be there? Because if the actual y value doesn't exist, you don't know. So it's the approach to y value as you approach on the x values from both sides, like what's the y value there as you get closer and closer and closer. So the notation looks like this. LIM is just an abbreviation for limit. And then underneath the limit is this little like baby subscript there that tells you what x value you're approaching. So this will say x, arrow, and a number. You might have seen that notation when you did end behavior in like math 3 and pre-calculus. They sometimes would use that word limit. It's the same thing. It's giving you the x value that you're approaching. And then here it might say f of x, g of x, h of x, or it might give you the full-on equation there. Equals, and then the answer is that y value, and the y value has to be like an existent real number. So it might be like 10 or 21 or something. It should not be infinity or negative infinity. I know you used that with end behavior, but when you did end behavior, you would have an arrow there instead of an equal sign. The equal sign is telling us it should be a number. If it's going to equal a value, it should actually be a value. So infinity, we'll talk about what happens when you do get infinity. The approach value, C, means you're coming from both sides, the left side and the right side. Sometimes your little number here, whatever it is, will have a dash with it, which means minus, like a minus sign, or it might have a little plus sign with it. And that designates that you only have to actually come from one direction. Like the band. Are you guys too young to know One Direction? Too young. Okay. All right. So from the left or from the right also might come into play if there's a little like dash there. I'll show you that as we get to it. But this is the overall notation. So all our problems are going to look like this. Find the limit of whatever function. There's 3 ways we're going to ask you to find a limit. One is by using a table. And I'll tell you what, the tables can be kind of tricky because there's a lot of decimals going on. So you have to concentrate on what's happening with those decimals, like what number are we approaching and from what direction. Graphically means we're going to give you a graph already, and then you look from the left or from the right or from both sides and see what y value you're approaching. Or the most difficult is analytically having an equation that you have to work out. And so we'll break this up. We're going to do limits over the course of the next few days. We're not going to tackle number 3 at all yet. We're going to talk about 1 and 2 today. We might not even get to both of those today. Okay, so this is a crazy function. It's a piecewise function with a lot of different parts to it. So kind of look at the graph. You got a horizontal asymptote here. You have a couple holes. You've got a couple of like dots piecewise that are drawn. So this is our function that we're going to look at. We're going to talk about some limits problems with that. So underneath here, we're going to fill in our values. So let's start with B. I know that's not the first one, but let's start with B because that's pretty straightforward. So B says find the limit as x approaches -5 of f of x. So f of x is this graph. And again, a limit means the y value that you approach as you go to this x value. So that means I'm going to look at my graph at -5. And at x equals -5, I'm going to approach from the left and from the right. Change color. So as I approach from both directions, I see that there's a hole in the graph. And a hole in the graph is not a problem because we don't ever actually plug in -5. We're just approaching -5. So then I'm looking at the y-axis to see like what y value am I approaching? Now, what's the actual y value? What is the y value that I'm approaching as I get closer and closer? And so this answer is going to be 4. But of note, I do want you to realize that is not f of -5. The function value at -5 is this dot down here. At -5, I would go to that dot and be like, oh, f of -5 has a y value of -3. But I didn't ask you about the function value. I asked you about the limit value. And the limit value is the y value that you get close to, that you approach. So like this y value is coming at 3.9, and this is like 4.1. As I get closer and closer and closer, I'm approaching 4. You get infinitely closer. It's close, 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 close. But then you never actually get to -5 because if you did, your answer would actually be -3. So a limit is the y value that you approach. Okay. Let's try C next. So limit as f of x approaches 4. So I'm going to go to x equals 4. From both sides, I kind of trace my graph out. And I look at it and see, well, what's the y value as I approach 4? And this one's very straightforward. There's not even a hole in the graph. It's just the y value is 4. Now the actual y value is also 4. So this is a problem where the limit value and the y value are the same. Sometimes they're the same, sometimes they're not. They're not the same. Seem pretty straightforward so far? Okay, let's talk about A. So A has a couple things. First of all, it's got this little dash right here. That's actually a minus sign. That means from the left. So that's called a one-sided limit. And a one-sided limit helps us examine a function, especially a piecewise function, to look at the overall limit. So right now, we're just going to look at the left side of -3. So I'm going to go to my graph at -3, and I'm going to go a little bit left of there and try to figure out what the y value is approaching. So here's -3. To the left of there, the part of the graph I'm looking at has an arrow going up infinitely. So this, for now, I want to put an equal sign, even though it's not an equals. But temporal, and put equal sign saying infinity because the y value is growing exponentially. Now, the thing is, you can't have infinity as an answer for an overall limit. You have to have a real number. But this is a one-sided limit. A one-sided limit is helped to use to help to find the overall limit. So right now, I'm going to leave this as infinity. But when the question says, but then what's the actual limit at -3? My answer is going to be does not exist. But if I'm looking at just a one-sided limit, it's like a part of the problem. So if it's a one-sided limit, I want you to leave your answer as infinity. But then keep in the back of your mind that if I was just doing -3 without that dash, the left sign, if I was coming from both directions, the overall limit would have been does not exist. Because you have to have a number for your answer for an overall limit. On a one-sided limit, it's okay to leave infinity or negative infinity in there, just like you did with end behavior. Okay, let's go to the next row. So letter D is x approaching 2. What do you think the plus sign means? From the right. Yes, very good. Okay, so pretty intuitive there. So just go to x equals 2. And at x equals 2, I go to the right of 2 and I look at that part of the graph. And I look at what is the y value that I approach there. And the y value that you get closer and closer to is 8. Now I know there's a hole in the graph, so the function value isn't necessarily, but the limit from the right is 8. Yes, question.
These are all, like problems, so we can even have full value to,
Not necessarily. It depends. Okay, so good question. So the question is, if you have a hole, is there always going to be a function value maybe used somewhere else? On this particular graph, that is true. There is a function value below it, right? But let me give you the example of absolute value x over x. That picture, if you were doing the limit from the right and the limit from the left, you'd have different answers. And the function value doesn't exist there. So it's not necessarily always going to have a hole with a dot filled in somewhere else. So a hole might have a dot somewhere else, it might not. It depends on the graph. Good question. Okay. Let's see. So we're on E. Okay. Limit as x approaches 2 from the left. Okay, you guys try it. It's kind of like it's a decimal. That's fine. Just put what you think the decimal is. Okay, so from the left, I'm guessing it's like 1.2-ish. But did you get 1 point something? Just from the left side. So just from the left side, this would be like 1.2 something. 1.3. Like, we're not going to do an exact science because we don't have an equation to plug into. All right, letter F then is like, oh, let's do 2. The whole thing, 2 from the left and from the right. Okay, so when I look at 2, now I'm looking at both pieces, both of my one-sided limits from the left and from the right. And I have kind of a problem because they go to different numbers. And if your limit goes to different numbers, your answer will be does not exist because, and I'm actually going to move this up so I can write this with really nice notation. Okay, write small here, please. We're going to do good notation here. Okay, so we're going to say this is a does not exist. And a does not exist takes a little more work because they're going to want you to explain why. And our reason why is that the left-sided limit and the right-sided limit were different. So I can't have an answer there. The way you write that looks like this. Your new limit as x approaches 2 from the left of fx does not equal the limit as x approaches 2 from the right of fx. So sometimes your limits will have answers. Sometimes there will be a does not exist. And we're just doing a small intro to this today. We'll be doing plenty of this so you understand, like, when will I have does not exist? When will I have an answer? But this is one that didn't exist because we can't get one single number. They were different numbers. Okay, we have 3 minutes and we have 3 problems. Let's see if we can work through these ones. Okay, so limit as x goes to -1 of f of x. So -1 is here, and on my graph, from both directions, the y value there is 0. So my answer is just 0. Both directions came to the same number. So my answer is just a 0. If there's not a minus and not a plus, you have to check both directions. Okay, and then in my last 2, this is going to be very similar to end behavior. What is happening on the left side of the graph as your arrow goes towards infinity? And what is happening on the right side of your graph as your arrow goes to positive infinity? We're looking to see if any y value is approached over on the left and the right. So as x goes to negative infinity, that's your left-hand behavior. The y value there is 2. We'll fill that in a second. On the right, that rightmost arrow, that end behavior is going up to infinity. That y value is infinity. So the way I want you to write these answers, so this one was 2. This one is infinity, and it's an overall limit. So we have to put does not exist because it's infinity. If you're doing an overall limit, your answer should be a number. Otherwise, it doesn't exist. You can't have an infinity as an overall limit, just a one-sided limit. Okay, we will pause. We will do more tomorrow. Your homework for tonight is to work on the circuit and make sure your web assignment is verified. You should have too much for calculus tonight. That'll be nice. Just because it's the one side, it can help you determine like the overall. You may grab your phones, yes.